Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. In this meeting, we would like to present our discussion about smart packaging with quality monitoring. Before we start, we would like to introduce our group member. The first one is Ananda Amar Zahroni. The second one is Grendhaka Kagaheswara. The third one is Muhammad Fabio Fairano, myself. The fourth one is Sania, Azmi, Aniqoh. The fifth one is Eka Nuraini. And the last one is Putri, Wahyu, Ningtyas. Next.
At the times, the important things in innovation, the field of production is about the torrents and distribution of food in order to overcome the problem of hunger that still plagues in the summer parts. All have the same goal of getting a good method done to prevent the spoilage of the food. Apples are one to commodities in the city of Malang, which until now still require a good packaging method to maintain its quality until it reaches consumer. This is because many harmful microorganisms can affect fresh produce. Most of these pathogens are carried away during transportation and storing and due to incorrect packaging techniques.
Purposes importance of smart packaging and its relationship with freshness sensor. Packaging of fruits and vegetables is one of the most important things to do before the products are transported and sold to consumers. Primary aim of packaging is to ensure that the product inside are protected from damage and to provide accurate and thorough information about the origin, trade, nutrition, etc. of the product within them. This is what makes us think about how a packaging can be monitored and controlled regarding the quality of the product so as to provide better quality, nutritional value, and safety customer.
Factor that cause fluid quality decrease. Respiration. The respiration rate that increase continuously cause fruit and vegetable to ripen quickly until they eventually rot. Microbial pathogen. Humidity. Low humidity can cause moisture loss in fruit, affecting physical texture and taste. High humidity can speed up fruit decay and rot. Temperature. Inappropriate strength temperature may increase repetition and water loss, leading to premature ripening. Surrounding atmosphere, high oxygen level can accelerate the ripening process of fruit and increase the growth of organism. To low oxygen level can cause cell death and the premature decay.
The next is schematic diagram illustration, the detail of a smart food packaging system. This now is about sensor input like spoilage, ripeness, time length, etc. Read by sensor signal and calibrate in the form of sensing electrode, signal transduction, and sensor packaging so as to get to the output color, fading, voltage, etc. Sensors that can monitoring the fruit. RFID-based sensor system. Intelligent packaging can also make use of radio frequency identification device, or can call RFID technology to track and identify the product quality sensor during storage and transport in containers. The next is about carbon dioxide non-dispersive infrared, or can call NDIR sensor. Non-dispersive infrared NDIR sensors can help to ensure proper packaging condition. And NDIR sensors use infrared light absorption to determine the concentration of specific gases.
The next is classification of sensor for monitoring freshness of fruit. There is two type of classification of the sensor. The first one is direct detection. Direct fruit freshness sensor can detect or sense the freshness level of fruit based on unique markers or compounds. Conventional type of direct food freshness sensor include spoilage, ripeness, leak, microbial pathogens, ethylene, and senescence indicator. In most cases, the sensor contains a color indicator for easy visualization of freshness level by the naked eye. The second one is indirect detection. Indirect detection of a fruit freshness detection relies on indirect freshness markers including temperature, storage time, and associated technologies such as RFID or radio frequency identification. The indirect sensor should indicate the freshness monitoring results in terms of change of color and electronic signal output when exposed to abnormal storage temperature and or humidity.
Next one is the challenge and the prospect. The first challenge and prospect in the smart packaging system is the limitation in sensory technology. Their usability, specifically size and cost, make it difficult to incorporate them in large-scale package containers. The second one is waste management. Most of the material they use is neither biodegradable nor easily recyclable. Indeed, some form of packaging that utilize specific chemical compound need to be carefully regulated during disposal. The last one is the conclusion. In conclusion of our discussion, current smart packaging system along with embedded sensor and communication technology can provide means of monitoring and regulating the quality of package mechanism to maintain food quality and mitigate any harmful environmental elements. This technology can benefit the global food market by reducing the amount of preventable food spoilage that contribute to wasted resource. The emergence of smart system in food processing application is still recent and has many more years before it can be considered a routine practice in the industry. That's it from our discussion. If there are any misword, we would like to apologize professionally. Bila taufiq wal hidayah, wassalamualaikum warahmatullahi wabarakatuh.